Hello guys, today I'm going to explain you how can we solve this problem from Leetcode's May challenge. This is the kth smallest element in BST. So we are given a binary search tree. We need to write a function kth smallest to find the kth smallest element in it. For example, here the kth smallest is first element, the element with value 1, and the kth smallest, that is the third smallest element, here would be value with the element with the value 3. So we know that the binary search tree follows a property where the root value is always greater than the left child and smaller than the right child, or also we can say that the left child in BST is less than its parent and the right child is greater than its parent. And if there is another property that if we do a in order traversal, we always get a sorted list out of the binary tree. So let's see how we can solve this using some examples. So let's use in order traversal on this particular binary tree that I've created and see how it is going to help us. So yeah, as you know that binary tree is binary search tree. In the binary search tree, the in order traversal is going to give us the sorted list. So how does a in order traversal look like into binary tree? So what we do is keep on traversing until we found the leaf node. We keep on traversing on the left node until we find a node which is not having any child, any left node. And what we also do is maintain a stack where we keep these nodes keep inserting this node into the stack. For example, in the first case we inserted 12 and then 4 and then 3 and then 1. Then in the next step what we do is, when we see that there is no left child of this node, we pop this one out and then check if there is any right child or not. But before checking, what we can do is pick this element and put it into a queue. So this is going to be our first element, the smallest element, and then we can check whether this particular element has any right child or not. In this case it does not have, because it is a leaf node, so we can just continue popping the next element. So let's pop the next element out. So when we pop the next element out and we see that out of the stack, we see that this next element is also having one element on the left and which is already visited, and there is no right child. But before checking these two, we are going to just simply put it in the queue, and this would be our second smallest number. And then we check that this does not have any right child, and the left child is already visited. So we are going to keep this out of the stack, and then we are going to check it for the next element, that is the 4 on the stack. Pop 4 out of the stack, and then we check that its left child is already visited. In fact, in all the cases left child would have already been visited, so we don't need to check that. And then we check if there is a right child or not. There is a right child, so and before doing all of them, we are going to push this one into the queue. So we now know that we have found till now the top 3 smallest element. If we needed to find the third smallest element, we could have just stopped here all the in order traversal and return this element itself. Otherwise we are going to pick the right child because it is available in this case. So we are going to pick the right child and do a in order traversal on the right child. So what it will do is it will keep on pushing this 7 and 6 as well on this stack, which is the case. So what we are going to do is we are again going to keep on pushing this element into stack until we reach a node where there is no left child. So as you can see, this what I've done is first push 7 and then push 6 onto the stack. Then what we are going to do when we reach a leaf node, a node where there is no child, we again pop it out of stack and then check if it is having any right child or not. There is no right child, so it is a leaf node. We are going to also, before checking, we are going to push it into the queue. That means we have found the 4th smallest element. and then we'll keep it out of the stack. Then we are going to check for the next element into the stack. uh, we pop the next element out of the stack, we put it in the queue so that it marks that we have found fifth smallest element, and then we check for the right child. We have a right child, then we are going to just push this right child into the stack as we did for 4. We found 7, so we pushed all the left child starting from 7, but in case of 10 we don't have any other child for 10, so we just push it there. Alright, so what we are going to do then is pick 10 out of stack, and we see that we are first going to push it into our queue. That means we are found 6 smallest element, and then we check that this is a leaf node, so we are not going to do anything. The next element that we are going to pick out of the stack is 12. Let's see how it works. So we pop 12 out of the stack, and then we saw that there is right child on of it, so we push this one into stack, and also before pushing we mark that we have found the 7th smallest element, and then we pick 14 out of the stack, and we realize that this is a leaf node, and also this was the last element out of the stack. So we know that we have found all the, we have done the in order traversal, and we have found all the elements in the sorted order. So as you can see that now after doing all the in order traversal, we are left with empty stack. So there is no element in the stack. That means we have traversed all of them, and also you can observe that these are all in the sorted order. So we can keep track of how many elements that we have found till now, and yeah, instead of storing all of them, we could simply return as soon as we found our kth element. For example, if we would require to return 4th element, we could have simply stopped here, apart from doing the complete traversal. So let's see how we can code this now. Now let's try to code our algorithm. As you can see, I have already solved this problem in a recursive manner. Let me try to solve this in the iterative manner as well. So what we just discussed is we would need a stack of tree node, and let's call it stack, and what we decided is to keep on putting the left child of this root node onto stack. So we can simply put the first root and then just assign root to be root's left value, right? And then what we need to do, we need to once we reach the leaf node or a node where we don't have left child, what we were doing is we were popping out the first element from node from stack. Let's call it TP, or it should be st dot top, and explicitly pop it out. Then what we are supposed to check is if this is the element that we want to return. That means if minus k is equals to 0, we could simply return this TP of val. Otherwise what we could do is make this node as the right child of the node as the current node. Sorry, this should be TP of right, and then we need to recurse again. So to do that, we can, to recurse as in to try this whole thing again, we can again do this in a while loop. And as you can see that now what could happen, that we don't push anything onto stack. So before popping out, we can simply check if our stack is empty, then we can simply break out of this loop. And if we have reached the end of the tree and we don't find our element there, that means if the k is greater than the size of the tree itself, that but it's written that we don't find such situation, but just to handle that case we'll return int max. Let's see. Alright, it seems to be working. Accepted. Right, thanks for watching this video, guys.